our notes on lesson 3 for inverse functions. So let's get started here. Oh, hate these pens. So anyways, a function has an inverse if and only if it is one-to-one. So this is the existence of an inverse function theorem. This is actually a theorem. I don't know why we don't stress theorems anymore in calculus. And then number 2, if it's strictly monotonic on its entire domain, it means it's either increasing or decreasing on the entire domain, then it's one-to-one and therefore has an inverse function. So notation for these inverses, let's tackle that first. So as a reciprocal, this is not an inverse. This just means 1 over x, okay? Reciprocal is not an inverse. It's not an inverse. Now the inverse literally means that it's the inverse of f of x. So given a function, f of x, the inverse function is numerically defined to be the function that results from switching the domain and the range of f of x. So if you were going to look at f comma xy, now here's the domain, here's the range, then f the inverse of that function xy is now the range, and y values are now the domain. That's a way of looking at it. Graphically, what we know is that this inverse is a reflection. It is a reflection of f of x over the linear equation y equals x. Analytically, what revisiting, people always wondered why they had to do the work they had to do in algebra 2. The composition of a function and its inverse equals x. Similarly, the composition of an inverse and its function should produce x, right? So inverses and tables. Inverses and tables. This is considered the two functions, f of x on g of x, right? So I know x has become y. I'm going to highlight because it makes my life easier. Answer the following questions. So I need all the y values of g. So that's going to be those x values there. All right. That means the corresponding domain would become the y values of g. So I have 1, -2, I have -2, and 1. Similarly with the function f of x and its inverse, x values, corresponding y values would become the x values of the inverse. So now it wants me to find the value of this. So I'm going to use this table for any function. I'm going to use these tables for any inverses. So f of 1 equals 2, right? And then if I go to the inverse here, right, the inverse table, I get equals 1. And what this is proving is, remember, f of any x, the composition of any x is just x. The composition of any inverse in a function, and then similarly, the composition of any function in its inverse is just x as well. So this is a composition of a function of an inverse and its function. This is not a composition of an inverse and its function. This is a composition of an inverse and its function, and I should get one. I should get one here. But let's just check and make sure. Let's go through this. So we're referring to this table here and this table. So f, the inverse of 2 is 1. And the inverse of 1 is negative 2. All right, so the inverse of this should be 1. So let's just check right here. The inverse of 1 is negative 2. G of negative 2 is 1. And the inverse of 1, make sure I put my equal sign, right? Inverse of 1, well, I don't have that. I don't have this. And it's undefined. This is undefined because we don't have values for that. Okay. Now, finding a formula for derivative of an inverse. So let's use the chain rule on this. Let's use the chain rule. That means we're going to take the derivative of both sides. So d. So we're very. I want to be very cautious here when we have this going on here. You have to take the derivative of both sides, guys. So the derivative here is just going to be 1. All right. And of course, if we're using the chain rule here, this is going to be f prime of the inverse of this function. And then the derivative of that inverse. So I'm going to just put that derivative portion right here. And so we understand that that's not a 1 because they can be tricky. All right. Now I'm going to solve for this derivative. So I'm going to divide both sides by all of this. So I have f prime of this inverse, both sides, f prime. I'm going to make a little 1 right here so we can distinguish between that prime and the inverse. This cancels out, and I have finally a formula. Unless you want to go through the chain rule each time, I finally have a formula for this inverse. So what we have here, this is f prime of that f prime. So let's make sure that's a prime. We have a little 1 there. We want to be very cautious about the notation here. So if you have both equations, you can easily get that answer for that derivative of that inverse. So it says suppose that f of x equals 3x plus 2. And so I'm going to write that up here. F prime to the negative 1 of x equals 1 over f prime to, okay. So I just wanted to write that out. Anyways, so suppose that this is true and this is true. What is the value of f prime of negative 4? F negative 1 4 times. So I'm going to write that out, what that looks like. And I have f prime of to the negative 1. And I probably should, it probably would be better to do it with the notation that they're using, which is to put that derivative on the outside so we can see it. So let's do that. put that prime on the outside. This equals 1 over f prime of f to the inverse of x. Okay, so they give you the function for f, right? I need to know what the inverse is. That's where I'm going to start. So let's go back, let's throw back, we'll do like a little throwback here. And we're going to work with this inverse. That means that this value is a y value. Now you could find this inverse, or we could set this equal to y. So f of x equals 3x plus 2 and solve for that x. So solve for this domain, which is the range right here. It's like working in reverse. 3x plus 2. I'm going to subtract 2 on both sides. I get negative 6 equals 3x. Divide both sides by 2, and x equals negative 2. So this is the y value. This is f, okay, the inverse when x equals 4. So what I have so far, this equals 1 of f prime of negative 2. Now I'm going to find the derivative of f. So f of x, f prime of x, equals 3. That means when f prime is negative 2, I'm going to get 3. All right, so far so good. So that means this equals 1 over 3. And I'm done. All right. So let's move to another problem. Says for each problem, let f and g be differentiable functions where g of x equals the inverse of x for all x. So, okay. All right. Now, I know that this is what we have here. I want to find the inverse of negative 2. So I'm going to write, you could write this as the inverse of 2, which is the prime here. This also equals g prime of negative 2. I don't know what makes it easier for you, but let's go ahead and write this out. This equals 1. If it helps you, we could write that as g 1 over let's see, 1 over it made this so complicated, or I made this so complicated for no reason. So 1 over, I'm going to write this f prime. I should have made this smaller. F prime of f of 1 of x. Okay, so this equals 1. I'm not sure which one's the best approach here, so I'm just going to go ahead and write g prime of negative 2. Oh, not prime, because that's just the inverse. It's just the inverse. G of negative 2, right? Now, let's see what we have here. We know that f of 7 equals negative 2. That means the inverse would be, let's write that out, the inverse of negative 2 equals 7. That means the inverse of 1 equals 5. And then they have f prime of 7 equals negative 1. That means the inverse would be negative 1 comma 7, right? And all that good stuff. But we're gonna not do that with these derivatives because that might be not efficient. All right, but we have everything we need probably. So I need the inverse of -2. That's 7. That's 7. Didn't really have to write it out, but it just definitely helps. So 1 over f prime of 7. And do I have that? Yeah, it's -1. This equals -1. And it looks hard, but it's not, guys. So just write it out. All right, so 1 over f, so g prime of -1 equals, I'm just taking this formula, and I just have to recognize that this is the g is the inverse of f, right? So I want to know what's going on when the y value for f is -1. Is there anywhere where the y value for f is -1? I think this is supposed to be a -1 right here. So yeah, it is. So this is 1 over f prime of -5. All right. Because remember, g prime, no, g of 1 equals f, the inverse of -1 equals -5. So remember, we switched the x's and y's, and that's all we're doing. So 1 over f prime of -5, here it is. It's just 1 over 6. So not hard stuff, but kind of, it can be complicated. So it says, given all this information, it says the table below are the values of g and its derivative g prime, and select the values of x. So you can use this h of x. I'm not sure what complicates it for you, or we could just say the inverse of 7. So whichever one works for you. I'm going to go with this right here because the formula makes it a little bit more um, so this easier. So g prime of this composition, right? So we're looking at 1 over g prime of g, this inverse of 7 here. All right. So I'm going to go find 7. It's right here. So the inverse, so this is the x values for, if it helps you to go ahead and switch those up. All right. So basically 5 and 2, 7 and 4, so on and so forth, right? So 10 and 5, so on and so forth. So I know that this equals 4. So I hope it's becoming a little bit clear. All right, now I just need to find g prime of 4, go to 4, and I get -2. Pretty straightforward. So here, I'm going to use g. So 1 over g prime of this inverse of g, right? So let's see here. I'm going to write the rest of these 4 and 10. All right. So just filling this in, I have 1 over g prime, this inverse of 2, okay? This equals 1 over g prime of, go find 2 for the inverses, and it's 7, okay? And then I go to my table for 7, and I get -7. And I'm done. So let's work with some equations. It says find the equation of the tangent line of this inverse at x equals 2. So, all right. So the point of tangency is going to be x and then g, the inverse of x, so that y value for it. So that's going to map onto, if I go to this table, I go to 2 and I get 7. So that's my point of tangency. Now the slope of this at 2 is right here. This slope is just a derivative. We already found it in number 12. It's just -7, guys. And then I just use point slope form. We don't simplify. Okay. And I'm going to put a little -1 so I know it's the inverse slope of g. X minus x of 1. Just plug these things in. I get y minus 7 equals -7 times x minus 2. Look at number next. We have a point of tangency here. And I have x of g maps onto, if I go to where 7, I have 7 comma 4. Now, let's see if I got that derivative, and I did it in number 11. So g prime, g to the inverse of x, remember my prime goes outside to show that this is derivative, is just -2. Okay, write my equation in point slope form. Inverse, get y minus 4 equals -2 times x minus 7. And I'm done. And that's all she wrote, guys. So I'm going to end it there and start the next part in a different section. Well, actually, I'm going to do these last two. It says for each function, its inverse equals f of x. Not really sure why I decided to do this, but I think I was trying to not complicate things, but whatever. So, when x equals 6, let's make a little table here. Okay, x and g of 6. Okay, so we have at 6, I have 24 plus 4 is 28. Okay, so I'm going to go x and g prime of 6. Okay, at 6, let's see, the derivative of g of x is going to be 4. So it's just going to be 4 when it's a constant. All right. So this derivative, remember, I'm just going to call this inverse of 6. Makes my life easier. So the inverse of 6 equals 1 over g prime of, make it as a composition of the inverse. All right. So let's erase that little x and put a little 6 in there. Okay. Now, how do I to get this value. So remember, we just switch the x's and y's. We take that same equation and we solve for x to get this value. I'm getting this value by plugging in 6 for the y value here. All right, so let me erase that because that's not the one I wanted to highlight. So we're solving for x to get this y value for the inverse, if that makes more sense. Okay, so I'm going to subtract 4 on both sides. I get 2 equals 4x, and x equals 1/2, and that is g prime, g to the inverse of 6. So I'm going to replace it. 1 over this composition, and honestly, it's literally just going to be 4, because any value would just be 4. And that's it. That's all she wrote. All right, let's look at number next. And we're, like I said, I'm going to change this to the inverse of 1/3, and that derivative. All right. So I'm going to look at this one, that derivative. Okay. So we're going to use this space over here, and I'm going to get the derivative of 1 over 5x. So g prime of x equals negative 5 minus x. So let's make this 5 minus x to the negative 1. So I'm going to multiply a negative and another negative, and I'm going to subtract 1 to get this answer. Now g prime of any number that I need, I don't know yet, we'll see, and go from there. All right, now I am going to write this out. This equals, this derivative of this inverse equals 1 over g of the inverse of 1/3. So how do I get this answer? So we're going to set this equal to 1/3. Okay, I'm going to cross multiply, get 5 minus x equals 3, and x equals 2. All right, and that's correct. 5 minus 2 is 3. All right, so this equals 2. And I'm going to look for g prime of 2. All right, so I'm going to plug this number in, and I have 1 over 5 minus 2, and that's squared. That's 1 over 9. I'm amazing. All right, I'm going to end it right there, guys. That was a long video. Inverse trigonometric functions is going to be in a different video. Have a good